So, a very good morning to all. I hope my voice is
Morning,
audible to
sir.
all of you. ठीक है? चलो. So, welcome class 11th. This is your second class, right? So, in this class, we are going to start our first chapter, that is mole concept. So, I'm going to, quickly revise this mole concept, right? जल्दी जल्दी करेंगे इसको हम लोग mole concept को पूरा और ट्राई करेंगे कि एक ही क्लास में अगर हम इसके सारे इंपॉर्टेंस को कवर कर सके तो इट इज लाइक अ क्रैश कोर्स फॉर द मोल कॉन्सेप्ट, राइट? जिसमें हम इंपॉर्टेंट चैप्टर्स को कवर करेंगे एंड ट्राई टू फिनिश इन अ वन क्लास, राइट? चलो, सो जल्दी से सभी ज्वाइन कर लो एंड if you face any problem regarding the voice or display, then you can text me or just unmute yourself and just talk to me, right? If you face any problem, right? तो चलो शुरू करते हैं आज की क्लास. So I'm Vivek Tiwari and today we are going to discuss the mole concept crash course. So this session is going to be a mole concept crash course in which we are going to cover all the important concept of this chapter in a in a fast method, but we are going to cover all important topics, right? It's not like that कि हम important topics को छोड़ देंगे, skip कर देंगे. No, we are going to cover all important topics, right? So let's start with the today class. So first of all, we all know beta what is mole, right? What is mole? Can anyone define mole? What do you mean by the mole? Right. So what is mole concept basically? So one mole of substance always mean 6.023 into 10 raised to the power 23, right? So this means 6.023 into 10 raised to the power 22, three entities, right? That substance is called Avogadro number. Just like हम लोग बोलते हैं ना एक दर्जन है. What do you mean by some एक दर्जन है? एक दर्जन means something which is in 12. हम लोग बोलते हैं कि ये एक दर्जन हो गया. सो उसमें क्या हो गया कि इसमें कोई भी क्वांटिटी जिसको बोलेंगे 12 ना बोल के एक दर्जन बोल सकते हैं, राइट? सिमिलरली अगर मुझे रिप्रेजेंट करना हो, इफ यू वांट टू रिप्रेजेंट this much of entities, that is 6.023 into 10 की power 23 entities. So instead of saying this much of entity, we can suggest a name like mole. So one mole is always equal to, whether I'm talking about oxygen, hydrogen, doesn't matter. One mole of any element, any atom, any compound or any molecule contains this much of entities. That is 6.023 into 10 raised to the power 23. मतलब इतने पर्टिकुलर क्वांटिटी को हमने एक नाम दे दिया and the name is known as mole, right? So is it clear to everyone? So it is called Avogadro number or Avogadro constant and they generally represented by Na, right? Now the amount which weight exactly same as its formula weight in gram or atomic mass in gram or molecular formula mass in gram is known as 1 mole. So these all are the definition of 1 mole. Okay, किसको 1 mole तुम लोग बोलोगे? Now the amount which has the same number of entities, that is atom, molecules or other particle, as there are atom in exactly 0.12 kilogram or we say 12 gram of carbon C12 isotope. यानी कार्बन का जो C12 isotope है, we know ना what is isotope बेटा? Having same atomic number but different mass number, right? They are called isotope, like C12, C13, C14. So we have a different kind of isotope for the carbon. So 1 mole is also defined as the amount which has the same number of entities, that is atom, molecules or the other particle, as there are atom in exactly 12 gram of carbon 12 isotope, right? This number is equal to Avogadro number called Na, or we also known as Avogadro constant, right? Thus, the formula used to convert the amount of substance into mole is, this is very important, right? कि कौन सा formula हम लोग calculate करेंगे? What are the formulas used to convert amount of substance? देखो, there is a very good practical application of mole is what? The good application of mole, we can convert mole into gram, gram into mole. It means mole are converted into the gram as well as mole are converted into liter, Similarly, we can interconvert this thing as well, right? So thus the formula used to convert amount of substance into moles are following three formulas, right? The first one is number of moles of the molecule, जो तुम लोग 9th class से पढ़ते आ रहे हो. This is very simple, right? That is the number of moles of the molecule is nothing but weight in gram divided by the molecular or formula weight in case of salt, right? So number of moles of the molecule we can write as weight in gram divided by the molecular or formula weight. Similarly, number of moles of atom, so we can define number of moles of atom as weight in gram divided by atomic weight, right? Weight in gram divided by atomic weight. Similarly, the number of moles of the particle, so we can write number of moles of the particle as number of particles divided by Avogadro's number, right? Number of particles divided by Avogadro number, right? So this is how we can actually write the name, right? So thus the formula used to convert the amount of substance into moles are these three following formulas. I hope this is clear to all of you. सबको क्लियर है क्या? और anyone having any kind of doubt you can ask बेटा फटाफट. किसी को कोई डाउट है क्या?
नो सर.
क्लियर है? चलो ठीक है. So these three formula we are going to use for the calculation of number of moles of the molecules, number of moles of the atom, and number of moles of the particle, right? Weight in gram per molecular, weight in gram per atomic mass, number of particle divided by the Avogadro number. Clear hai? Chalo. Now, similarly, number of mole of gases, we can also calculate number of moles for the gases. How? Number of moles of gases is nothing but is equal to volume of the gas at STP in liter divided by 22.4, right? Always remember this is 22.4. This is in liter, right? So volume of the gas at STP in liter divided by 22.4. For example, if you want to calculate 1 mole of NaCl, right? So 1 mole of NaCl is what? Right? So 1 mole of NaCl means 6.023 into 10 raised to the power 23 NaCl units. Similarly, ये तो तुमने उसको मॉलिक्यूल के फॉर्म में लिख दिया, कंपाउंड के फॉर्म में लिख दिया. अब तुम इसको एटम्स के फॉर्म में लिखो. इसका मतलब they consist of 6.023 10 की power 23 units of Na plus as well as 6.023 10 की power 23 units of Cl negative. Similarly, mass of 1 mole of NaCl. So what is the mass of 1 mole of NaCl, beta? That is 23 gram. That is mass of Na, and 35.5 gram. That is the mass of Cl. Clear hai? 35.5 gram. That is the mass of Cl. The total mass of 1 mole of NaCl is 58.5 gram. Thus, we can say that 58.5 gram of NaCl contain this unit. इसका मतलब क्या हुआ कि 58.5 ग्राम NaCl के अंदर इतने पार्टिकल्स होंगे. कितने? That is 6.023 into 10 की पावर 23 units of NaCl. Clear है? While clear है सबको? How will you calculate? So we can say that now 1 mole of the compound is equal to the molecular mass. Similarly, we can say that what is molecular mass, right? What is molecular mass basically, beta? So molecular mass is nothing but it is the mass of 1 mole of the compound. कि 1 mole के अंदर जितने भी atoms हैं, जितने भी molecules हैं, उन सबका mass जितना होता है, that is called 1 molar mass, right? That is called 1 molar mass. So always remember, so we can write mole is always equal to the molecular mass. Mole is always equal to molecular mass. Clear hai? Chalo. So 58.5 gram of NaCl. On the similar basis, beta, if I'm ask you for a O2 atom, O2 molecule, ठीक है? O2 molecule, ठीक है? O2 molecule. जल्दी से बताओ मेरे को 6.023 into 10 raised to the power 23 molecules. इतने molecules का मास कितना होगा? मॉलिक्यूलर मास कितना होगा बेटा? इसका मॉलिक्यूलर मास बताओ. What is the molecular mass of 6.023 into 10 raised to the power 23 molecules of O2? जल्दी फटाफट. This is 1 mole now. This is nothing but 1 mole. So 1 mole is always equal to molecular mass. So what is the molecular mass of O2? So molecular mass of O2 is 32 gram. It means 32 gram consists of 6.023 into 10 to the power 23 molecules, right? So in 32 gram, this much of molecule of O2 is present. Clear है? तो अगर तुम किसी ने पूछा कि मुझे 10 ग्राम का बताओ, just calculate for the 10 gram. Then how will you calculate, beta? We know 32 gram contain this much of molecule. So 1 gram contains 6.023 divided by 32. So 10 gram contain multiply by 10. Just a unitary method, right? So by using the unitary method, you can calculate this thing. Clear hai? Chalo. So always remember, while solving problem related to the mole concept, always keep in mind the following points. What are the points, beta? Convert all in same unit. Always convert all in same unit, like mole, atom, mass. Always convert, either they convert mole, atom or mass into gram, or we convert masses into mole. So always convert all in same unit, then compare only. And moles is directly proportional to the molecules, right? So these are some important things need to be remembered while solving question related to this. ठीक है? चलो एक क्वेश्चन ले ले क्या पहले छोटा सा फटाफट बताओ. एक क्वेश्चन ले लेते हैं, इसको करने के बाद करते हैं. चलो. So basically chemical equation and the stoichiometry. What do you mean by this term? Chemical equation and the stoichiometry. So calculation based on the quantitative relationship between the reactant and product. Always remember, the calculation based on the quantitative relationship between the reactant and product are referred as stoichiometry. The goal of this calculation is to predict the relationship between the amount of the reactant and product of the chemical reaction. And always remember, never lose your goal while solving such problem, right? हमेशा गोल को आइडेंटिफाई करो कि निकालना क्या है, हाउ वो कैलकुलेट क्या करना है. So use mole concept very carefully and then also find the type of stoichiometry product before solving, right? So we are going to solve some numerical, इसीलिए मैं थोड़ा सा आइडिया दे रहा हूं तुम लोगों को, so चीजें एकदम क्लियर हो जाएंगी तुम लोगों को. So before थोड़ा सा समझते हैं what do you mean by the equivalent mass or equivalent weight. So ये equivalent mass और equivalent weight का क्या concept है basically? So mathematically we can write the equivalent weight of, acid, equivalent weight of base, equivalent weight of salt, equivalent weight of the atom which undergo oxidation and reduction. So we need to identify the how we write the equivalent weight for the particular thing, right? For example, for the metal, for salt, right? For acid, for base. So what is equivalent mass? First of all, so basically the number of part of the substance that combine or displace. ठीक है, ध्यान से सुनना. The number of parts of substance that combine with or displace directly or indirectly 1.008 part by mass of hydrogen or 35.5 parts of mass of chlorine, or we say 8 part by mass of oxygen is called equivalent mass of that substance. Always remember. So कब बोलेंगे equivalent mass बेटा? यानी the number of part of the substance that combine with, या तो combine हो और displace कितना directly, चाहे 1.008 parts of hydrogen हो या 35.5 parts of chlorine हो या 8 parts by oxygen हो. That is called the equivalent mass. Clear है? चलो. For example, if you want to calculate the equivalent weight of the metal, so what is the equivalent weight of the metal beta? Similarly, mass of the metal upon mass of the hydrogen displaced into 1.008. Similarly, instead of mass of hydrogen, if you are using mass of oxygen, then multiply by 8. Similarly, in case of mass of oxygen, you are using mass of chlorine, multiply by 35.5. Right? So this is the simple way how you will calculate the equivalent weight of the metal. ठीक है? चलो. Now, equivalent weight of an acid. So how will you calculate the equivalent weight of an acid, beta? So equivalent weight of an acid is equal to molecular weight of an acid divided by basicity. ठीक है, अब ये बेसिसिटी क्या होता है, लेट मी एक्सप्लेन, राइट. So basically if you want to calculate the equivalent weight of an acid, okay, and if suppose we have H2SO4, ठीक है, suppose we have H2SO4, right, and for H2SO4 this is an acid and you want to calculate the equivalent weight. So what is the equivalent weight for this? So similarly equivalent weight of H2SO4 is nothing but the molecular weight, that is molecular mass, and divided by basicity. Always remember, divided by basicity. Divided by basicity. What is this basicity? First of all, let me calculate the molecular mass of H2SO4. We know H having 2 into 1 plus sulfur having molecular mass 32 plus oxygen having 4 into 16. So in solving it comes out to be 98, right? So the molecular mass of H2SO4 is nothing but 98. Now what is this basicity? ठीक है, बेसिसिटी क्या है? तो यहाँ पे सिंपल देख लो, नंबर ऑफ रिप्लेसेबल H प्लस आयन. सो कितने रिप्लेसेबल H प्लस आयन है? बहुत सिंपल दिख रहा है, 2 H है जो रिप्लेस हो सकते हैं. अगर तुम इसका डायग्राम बना लो, अगर केमिकल बॉन्डिंग में वी आर गोइंग टू स्टडी ऑल दिस थिंग इन द केमिकल बॉन्डिंग एज वेल, कि हाउ टू ड्रॉ द लेविस डॉट स्ट्रक्चर, हाउ टू ड्रॉ द स्ट्रक्चर ऑफ द पर्टिकुलर salt or the acid or base, right? Let me draw the structure for this. If I draw the structure of H2SO4, structure of H2SO4 like OO, right, and we have OH. Here also we have OH. So here we have a 2 replaceable hydrogen atom. Here oxygen hydrogen having electronegativity difference ना, इसलिए यहाँ पे hydrogen क्या होगा बेटा, hydrogen easily निकल जाएगा. So here we have a 2 replaceable hydrogen, right? So that's why their basicity is 2. So what is the equivalent weight? तो equivalent weight कितना आ गया? That is 14. ठीक है, तो यही तो डेफिनेशन पढ़ा था कि equivalent weight is nothing but the number of replaceable H plus ion, ठीक है, या chlorine ion. So this is called the equivalent weight. So similarly, if you want to calculate the equivalent weight of an HCl, so we know that in case of HCl we have only one replaceable hydrogen atom, right? So the molecular mass is 36.5, and divided by the replaceable hydrogen, that is only 1. So in this case, the equivalent weight and the molecular weight remains same, that is 36.5. So I hope clear. How will you calculate the equivalent weight of an acid? जल्दी से confirm करो फटाफट. This is clear? Everyone got it? How we will calculate the equivalent weight of an acid? Chalo. On the similar basis, we also calculate the equivalent weight of a base, right? Equivalent weight of a base. So how will you calculate? By using the very much similar formula, just like the molecular weight of the base and divided by the acidity. Here we divide by basicity in case of acid, and in case of base we divide by the acidity. That is the number of replaceable OH negative ion. Okay? Number of replaceable OH negative ion. For example, in case of NaOH, we have a only one OH replaceable ion. So 40 divided by 1. So in this, the molecular mass and the equivalent weight are similar. Similar in case of MgOH2 beta. In case of MgOH2, we have 2 OH negative ion, right? So we have a 2 replaceable OH ion. So just divide the molecular mass with the 2. Here the acidity comes out to be 2. So this is how we can calculate the equivalent weight of a base as well. Now move to the next, that is equivalent weight of a salt. That is how will you calculate the equivalent weight of a salt. So basically equivalent weight of a salt we can calculate by using the formula, that is the molecular weight of the salt divided by the total positive valency of the metal atoms, right? So equivalent weight of the salt is equal to molecular weight of the salt divided by total positive valency of the metal atom. Clear? Let me explain with an example. So for example, in case of Na2CO3, right? Na2CO3. So molecular weight of Na2CO3 we all know 106, and total positive valency of the metal atom. So what is the positive valency of the metal atom in this case? We have Na2CO3. So we all know Na having +1 and CO3 having -2. So total positive valency. So total positive valency is what, beta? That is 2 now, because one sodium carrying plus 1 charge, so 2 sodium carrying plus 2 charge. Similarly, in case of NaCl, how will you calculate? We know the molecular mass of NaCl is 58.5. Huh? 58.5 divided by the positive, total positive valency. The positive valency of sodium is only plus 1. That is 58.5 divided by 1. So it comes out to be 58.5. So this is how we can actually calculate the equivalent weight of an acid, equivalent weight of a base, and the equivalent weight of for a salt. I hope clear है सबको? Anyone having any kind of doubt till? जल्दी से पूछ लो फटाफट. No? Sir, please repeat the previous slide. Previous slide. Beta, this one, definition of equivalent mass. ये पूछना है. Yes. Okay. Let me explain. So this is the definition of the equivalent mass. That is, how will you define equivalent mass or equivalent weight, right? We know we have a molecular weight, we know we have atomic mass, so we have a different kind of measuring thing, right? Like what is the molecular mass of a compound, what is the atomic weight. So just like this, we have equivalent mass or equivalent weight. What is this? So the number of part of substance that combine or displace, both are okay, right? That is the number of parts of substance that combine with or displace directly or indirectly 1.008 parts by mass. ठीक है, यानी जो हाइड्रोजन का 1.00 पार्ट मास को डिस्प्लेस कर दे, क्लोरीन के 35.5 पार्ट्स को डिस्प्लेस कर दे, and 8 part by mass of oxygen is called the equivalent mass of that substance, right? Mathematically, we can write as equivalent weight of substance A divided by the equivalent substance of B is equal to weight of substance A upon weight of substance B. Suppose if A is metal and B is hydrogen, ठीक है, मान के चलो, if A is metal and B is hydrogen or oxygen or chlorine, कुछ भी हो सकता है, then the equivalent weight of the metal. How will you calculate the equivalent weight of the metal? So equivalent of the metal is nothing but the mass of the metal divided by mass of hydrogen displaced into 1.008. Similarly, if you are using instead of hydrogen, if you are using oxygen, then multiply by 8. Instead of oxygen, you are using chlorine, then multiply by 35. Okay? So this is how you can actually calculate the equivalent mass or equivalent weight, right? Just remember one, this thing is very important, right? That is, how will you calculate the equivalent weight of an acid, base, and salt? Because in numerical, only these three things are come, right? That's why I explain this in a broader way, कि तुम इसको समझ सको. यही पेपर में सबसे ज्यादा आता है. How will you calculate the equivalent weights of an acid, base, and the equivalent weight of a salt? Like, clear है? Chalo. Now, the next thing is that is the equivalent weight of a substance that undergo oxidation or reduction, right? How will you calculate the equivalent of weight of the substance that undergo oxidation and reduction? For this, using the same formula like molecular weight upon change in the oxidation number. So this is also very, very, very important. That is, for the substance that undergo oxidation and reduction, how will you calculate the equivalent weight? So equivalent weight of a substance is equal to molecular weight divided by change in the oxidation number. Okay? Chalo, let me explain this with an example. For example, when the KMNO4, right? For example, when the KMNO4, okay? When the KMNO4 is react, right? When the KMNO4 is react with under the acidic condition, the change in the oxidation number. For example, let me write the equation. Here we have a KMNO4. KMNO4. when they react in the acidic medium, right, they converted into Mn+2. So here we know the oxidation state of Mn is 7 and here the oxidation number of Mn is +2. So कितने का चेंज हुआ बेटा? From +7 to +2 कितने का चेंज हुआ है? 5 का चेंज हुआ है. 5 का चेंज हुआ है ना, +7 to +2, right? So hence equivalent weight of an KMnO4 is nothing but 158. That is the molecular weight divided by the change in the oxidation number. So what is the total change here? That is +7 to +2. That is +5, right? So we can divide 158 by 5. So this is how we can actually calculate for the substance that undergo oxidation and reduction. Clear? Eh? Now, for volatile metal chloride, equivalent weight and the atomic weight are related as atomic weight is equal to equivalent weight into valency. So this is what. So these all are the method for the calculating the equivalent weight. So always remember, while solving problem related to normality or the problem related to the stoichiometric coefficient, many times you need this thing, right? That is the equivalent weight, or equivalent weight is given. By using the equivalent weight, you want to calculate the molecular weight. So these things you need to be remembered. Okay? Chalo. Now, what point needs to be remembered here? Atomic and the molecular masses of element and compound respectively are always constant, but equivalent mass may vary with the change of valency. बिल्कुल सही है भाई. Atomic and molecular masses of element are supposed to be constant, right? Sodium का atomic weight and molecular weight हमेशा constant ही रहेगा ना, 23 तो 23 रहेगा. But their equivalent masses may vary with the change of valency. ठीक है? Now the valency of that valency मतलब कैसे? जैसे मान लो यहाँ +7 to +2 हुआ तो divided by 5 था. मान लो कोई ऐसा रिएक्शन होता जहाँ +7 to +5 होता, so change is only of 2, तो 158 divided by 2 भी हो सकता था. ठीक है? So ये ध्यान रखना है. The valency of element forming isomorphous compound, that is the compound have the similar constituents and the chemical formula are same, like valency of chromium here, selenium and sulfur. ठीक है, सबकी वैलेंसी यहाँ पे सेम है. क्रोमियम निकाल लो, सेलेनियम निकाल लो, सल्फर निकाल लो, ऑल हैविंग सेम वैलेंसी ऑफ +6. ठीक है, सबकी वैलेंसी क्या है? +6 एंड +6. ठीक है, सो वैलेंसी ऑफ क्रोमियम, सेलेनियम एंड सल्फर. So they all are the valency of the element forming isomorphous. Always remember what is the isomorphous compound. Isomorphous compound means the compound that have the similar constituents and the chemical formula are same, right? For example, chromium, selenium and sulfur. Chalo. ठीक है, so I hope this is clear to all of you. That is how will you calculate this thing. The next thing is mass percentage. That is the percentage composition of the compound. So how will you calculate the percentage composition of the compound? So mass percentage of an element is nothing but is equal to mass of the element in the compound divided by the molar mass of the compound, multiply by 100, right? So this is how will you calculate the mass percentage of an element. That is mass of that element in the compound divided by the molar mass of that compound. ठीक है? चलो. So we have a one question. इसको सॉल्व करना है सबको हम लोगों को. तो फटाफट देखो क्या है क्वेश्चन में, क्या गिवन है हम लोगों को, एंड देन वी आर गोइंग टू सॉल्व दिस क्वेश्चन. ठीक है, फटाफट देखो क्या दे रखा है. ठीक है, तो दिस क्वेश्चंस आर कमिंग इन द जेईई मेन एग्जामिनेशन 2020. ठीक है, द रेशियो ऑफ द मासेज. जल्दी से एक बार रीड करो और ट्राई टू सॉल्व, फिर मैं इसको समझाता हूं तुम लोगों को. फटाफट जल्दी से रीड करो. ठीक है, कोई भी आंसर बताना चाहेगा इसका क्या? एनीवन? नो. क्या है भाई क्वेश्चन? क्वेश्चन बोलता है द रेशियो ऑफ द मास परसेंटेज ऑफ कार्बन एंड हाइड्रोजन एंड कार्बन एंड ऑक्सीजन of saturated acyclic organic compound X are given. ठीक है, So mass percentage are given, like carbon and hydrogen and carbon and oxygen. That is 4:1 and 3:4 respectively. Then the mole of oxygen gas required for the complete combustion of 2 moles of organic compound X is. ठीक है? So सबसे पहले we need to write the reaction for the combustion. So what is the combustion reaction, beta, basically? So in the combustion reaction, basically, we react hydrocarbon with the O2, right? We react this with O2. Now let's see the molecular formula. So we have carbon, hydrogen, and oxygen, right? So carbon, hydrogen, and oxygen saturated acyclic organic compound. So what do you mean by this term, beta? Saturated है, acyclic organic compound है. Saturated means alkane है, acyclic means cyclic compound नहीं. It means it is an alkane, right? So alkane के लिए combustion का formula लिखना है आप लोगों को. So for the molecular formula, let me solve this for you. Molecular formula. Molecular formula like CnH2n plus 2 and this is O2, right? So this is the molecular formula where M is the mass. So now calculate the percentage. So we know that the percentage of carbon. So carbon percentage is, that is 12n. Okay? 12n. 12n means what? 12 is the molecular mass of carbon and n is the number of carbon, right? So that is 12n divided by the molar mass into 100. Okay? Similarly for hydrogen. Similarly for hydrogen. जल्दी बताओ क्या होगा हाइड्रोजन के लिए? Molecular mass is 1 and multiply by 2n plus 2 divided by molecular mass n. ठीक है? चलो. Now similar for the O2. O percentage ऑक्सीजन के लिए कितना आएगा भाई? That is 32 molecular mass अपॉन में टोटल मोलर मास मल्टीप्लाई बाई 100, क्योंकि ये तो एक O2 दे रखा है ऑलरेडी, सो कोई इशू नहीं है. ठीक है? हमें कार्बन हाइड्रोजन का नहीं पता ना, O का तो पता ही है क्योंकि कंबस्शन हो रहा है तो O2 के साथ रिएक्शन हो रहा है. सो now you have to calculate the different percentage. So for to be saturated and acyclic, N is supposed to be what? जल्दी बताओ भाई. एल्केन के लिए फॉर्मूला क्या पढ़ते थे तुम लोग? किसी को भी याद है क्या? क्या होता था फॉर्मूला एल्केन के लिए? याद है? फॉर एल्केन व्हाट इज द फॉर्मूला? CnH2n plus 2. यही होता था ना फॉर्मूला फॉर एल्केन. CnH2n plus 2. Right? यानी to be saturated and acyclic, N is supposed to be 2. Always remember. यानी N कितना होगा? N is supposed to be 2. N is supposed to be 2. Right? So just put the values here for N. So we have percentage of C like 12 into 2, like 24 divided by capital M into 100. Similarly for hydrogen. Similarly for hydrogen, percentage divided 6 upon M into 100. And for oxygen percentage, we have 32 divided by M into 100. ठीक है? यहाँ भी 100 था. Into 100. Clear है? अब we have a given data. क्या given data है हम लोगों के पास? So we have a given data like we know that carbon percentage ratio hydrogen percentage is given. अगर हम इसको देखते हैं यहाँ से तो कितना आ रहा है? 24/6 और we say that comes out to be 4:1. यही आएगा. Similarly carbon percentage ratio oxygen percentage. So this comes out to be 24 divided by 32. So this comes out to be 3:4. ठीक है? तो बराबर आ गया बिल्कुल 3:4. So ये आ गया 3:4. वही गिवन है यहाँ पे 4:1 and 3:4. It means this is very much correct. ठीक है? ये बिल्कुल करेक्ट आया हम लोगों का. So X is, हमें पता लग गया साफ साफ कि यहाँ पे जो हाइड्रोकार्बन है X वो क्या है? So X is nothing but C2 H6NO2. ठीक है? Now just write the combustion reaction of this. So we know the how to write the combustion reaction. So let me write the combustion reaction like C2H6O2, and they react with. So they react with oxygen. So always remember how to write the reaction like 2 plus 6 by 4 minus 1 by 2. And that's O2. This will give us 2CO2 plus 6 by 2 H2. ठीक है? 6 by 2 H2. So on solving, what you will get, beta? That is C2H6 and O2 plus 5 by 2 mole of O2 will give 2 mole of CO2 plus 3 mole of H2. ठीक है? 2 mole of CO2 plus 3 mole of H2. So we can say that now कि 1 mole of C2H6O2 required 5 by 2 mole of O2. ठीक है? So 2 mole of compound X is required how much? So 2 mole of compound. 2 mole of compound X required 5 by 2 into 2. 2 cancel. That comes out to be 5 mole. So 5 mole of O2. ठीक है? So this is the correct answer. So what the question asks? एक बार दोबारा देखो इसको. So in this question they are asking the ratio of the mass percentage of carbon, hydrogen, and carbon, oxygen of the saturated acyclic organic compound X are given. Then the moles of oxygen gas required for the combustion of 2 moles of organic compound X. So you have to identify the कि 2 mole combustion कराना है अगर compound X का तो कितना mole oxygen का requirement होगा. So first of all we identify the compound X. So how will you identify the compound X, beta? Because the molecular formula, let us assume it is equal to CnH2n plus 2, right? So percentage of carbon is given, that is 12n upon m into 100. Percentage of hydrogen is given and percentage of oxygen is given. Now suppose n supposed to be 2, right? अगर n को 2 ले ले तो ये आया, इन दोनों का रेशियो निकाला. And if you find the ratio of carbon, hydrogen and carbon, oxygen, they comes out to be 4:1 and 3:4. It confirmed that is the hydrocarbon is nothing but C2H6O2. Now we just write the combustion reaction of C2H6 and O2 with this. So we'll get the 2 CO2 and 5 by 2 mole of O2. So 1 mole of C2H6O2 required the 5 by 2 moles of O2. So 2 mole of compound X required 5 by 2 into 2. So we get the 5 moles. Clear है? Right. So this questions कब आया था ये 2020 में. Clear है? चलो. Now some useful formulas related to the mole and concentration terms like number of millimoles. So how will you calculate the number of millimoles, beta? Number of millimoles is equal to molarity into volume in the milliliter. Or we say moles is equal to millimoles divided by 1000, right? So number of millimoles is equal to molarity into volume in the milliliter. Similarly, the number of equivalent of the substance is equal to weight upon equivalent weight. And number of milli equivalent weight is equal to 1000 into weight upon the equivalent weight. Clear? So these all are some important useful formula that relate moles and concentration terms. Concentration terms, we are going to study this thing in a later part only. That is molarity, all these things. So these formula relate moles and concentration terms. Okay? Chalo. Now, here one important thing is that is the density of the solution. How will you the density and the molality are related to each other. So density of the solution, if the density of the solution is given, then we can write density of the solution is equal to molarity 1 upon molality plus molecular weight divided by the 1000. Similarly, we can find the percentage by weight of the solute in the solution. That is the weight of the solute divided by the weight of the solution multiplied by 100. Similarly, we can find the percentage by volume. That is the weight of the solute divided by the volume of the solution multiplied by 100. Okay? Now, let me explain this with an example. Suppose if someone says 1 ml of 1 normality KMnO4. So what do you mean by this thing? that is 1 ml of 1 normality KMnO4 is equal to 1 ml of 1 normality H2O. Okay, always remember this is 1 ml of 1 normality H2O. Similarly, 1 ml of 1 normality Na2H2O3 is equal to 1 ml of 1 normality I2 solution. ठीक है, 1 volume of H2O2 solution is equal to 0.1785 normality of H2O2 solution. ठीक है, so if the two compounds A and B are neutralized completely each other, then the milli equivalence of A is equal to milli equivalence of B, right? Or we can write the molecular weight is equal to twice into vapor density. So this formula you need to remember as well, right? That is the molecular weight is equal to twice the vapor density. ठीक है, that is molecular weight is equal to 2 into my vapor density for the gaseous phase only. Now, basically, while solving the stoichiometric problem for the different kind, depending, yes. Okay, beta, okay, fine. So, stoichiometric problem for the different kind. ठीक है, कैसे समझते हैं stoichiometric problems को different kinds के लिए? Depending on the units, stoichiometric problem may be classified into the following relationship. कौन सा? So we have a three different relationship, that is mass relationship, mass volume relationship, and volume relationship, right? So in stoichiometric problem, so we classify this into a three things, that is the mass relationship, mass volume relationship, and the volume relationship. Fine. So this is how we are going to solve the stoichiometric problem of a different kind. So I'll explain you one each. Okay? Chalo. So basically, mole method. This is basically based upon the mole concept. So what is the mole method? So it involves the following steps. So you try to remember the step, then you can easily solve the question. I'm going to explain each and every step. The first step is write the complete and the balanced chemical reaction as per the information given in the problem. Okay? So always write the complete and balanced chemical reaction as per the information given in the problem. I'm going to discuss one problem related to each method, right? No worries. So first of all, write the complete and balanced chemical reaction. The second one is the stoichiometric coefficient in the balanced chemical reaction represent the relative number of moles of the different reaction component, right? Relate the amount of the reaction component concerned with the help of the mole. मतलब क्या बोल रहा है? Always that is convert relative number of moles of the different reactant component and relate the amount of reaction component concerned with the help of the mole. Like if 1 mole is required 5 mole of this, then 5 mole of required how many mole of this. So just compare each one like this. Okay. In step 3, calculate the unknown amount of the substance using the unitary method. So by using the unitary method, we are going to calculate the unknown amount of the substance. So let me explain this with an example, right? So this is an example. So let me explain this with an example so that you can understand the concept in a easy way. Clear है सबको? Chalo. So we have to calculate the weight of the carbon dioxide formed by the complete combustion of 1.5 gram ethane. Clear hai? So calculate the weight of the carbon dioxide formed by the complete combustion of 1.5 gram of ethane. ठीक? Chalo. So here amount of carbon dioxide you need to calculate formed by the combustion of 1.5 gram of ethane. So let me write the combustion reaction for the ethane. So we know the formula of ethane is C2H6 and they react with the O2, right? 7/2 O2. O2. So this will gives us 2 CO2 plus 3 H2. Clear hai? 2 CO2 plus 3 H2O. So this is the first step. Write the balanced chemical equation. This is the most important step. Write always balanced chemical equation. Now the second step is we know that 1.5 gram of ethane is given. Before this, let me calculate 1 mole of C2H6 having, can you calculate now? Number of moles into gram and gram into number of moles. So we know 1 mole of C2H6 contain how many gram? So it will contain 1 mole is equal to 30 gram, right? So 1 mole of this is equal to 1 mole of C2H6 is equal to 30 gram, right? And what is CO2 beta? So that is 2 mole. 2 mole of CO2 is equal to nothing but that is 44. Okay, that is 44 gram. So that is 2 into 44. So it comes out to be 88 gram. Right, this is called 88 gram. So now we know that the 30 gram of C2H6 required how many CO2 beta? How many gram of CO2? That is 88 gram of CO2. Clear? So 30 gram of C2H6 require 88 gram of CO2. So 1 gram of C2H6 require 88 divided by 30. So in this question, they're asking, calculate the carbon dioxide formed by the complete combustion of 1.5 gram. So 1.5 gram of ethane, that is C2H6, is nothing but is equal to 88 upon 30. And this multiply by 1.5. Okay? 1.5. So on solving, what you will get? You will get, that comes out to be 4.4 gram. So which option is correct, beta? That is D. जल्दी बताओ भाई, समझ आया सबको? Everyone got it? Yes. Yes, JNB अहमदाबाद, JNB भावनगर, फटाफट बताओ बेटा. Got it? समझ आया? How will you calculate the weight of carbon dioxide? By using the mole method formed by the complete combustion of 1.5 gram of ethane. So this question is from combustion. So first of all, yes sir, good. So in this question is from combustion. So we write the combustion of ethane, right? So combustion of ethane will get the 2 mole of CO2. So just we convert this mole into gram. So 1 mole is equal to 30 gram. So 30 gram of ethane produce 88 gram of CO2. That is 2 mole of CO2, right? 88 gram. So 1 gram of C2H6 produce 88 upon 30. So similarly 1.5 gram of C2H6 produce this much of this. Right? So this is how we will calculate this. Sir, can you provide the PPT to us after the class? Okay. I will provide this. We have some drive folder in which we are going to upload all this PPT, from where you will get all this PPT, right? So I'll upload in the drive. Chalo. The next problem is calculation involving percentage L. So how will you calculate the calculation involving the percentage L? And better, I'll give you one more question like this. Yeah. Can you solve one more question similar to this question? Like how many gram of oxygen are required? How many gram? How many gram of oxygen? How many gram of oxygen are required? How many gram of oxygen are required to burn 570 gram of octane? Right? So this is the homework question for you all. Try to solve this question. या अभी solve कर दोगे तो बताओ जल्दी. How many gram of oxygen are required to burn 570 gram of octane? फटाफट. I'll give you a hint. I'll write the combustion reaction. ठीक है? I write the combustion reaction for this. So octane having the formula C8 and 16 plus 2, that is 80, and they react with 25 mole of O2 to produce 16 mole of CO2 plus 18 mole of H2O. ठीक है? Always remember beta, number of mole of H2O is always equal to number of hydrogen, and number of mole of CO2 is always equal to number of carbon. Twice of the number of carbon, right? If they having C8, we having 16 CO2, and hydrogen is 18, then H2 is also 8, right? So always remember this concept. Now, can you calculate how many gram of oxygen are required to burn 570 gram of octane? So in this you need to calculate the oxygen. So I hope तुम सब लोग calculate कर लोगे. तो इसको प्लीज एक बार कैलकुलेट करना है. स्क्रीनशॉट ले लो अगर ले सकते हो, या नोट कर लो, जैसे भी इसको नोट कर लो एक बार एंड ट्राई टू सॉल्व दिस क्वेश्चन. ठीक है? तो अभी मिलेंगे हम लोग अभी क्लास में नेक्स्ट में, तो इसको यहीं से डिस्कस करना शुरू करेंगे. ठीक है? तो इसको मैं इसका आंसर्स तुम लोगों को बता दूंगा, फिर आप लोग इसको ट्राई करो सॉल्व करने का. ठीक है? सो दिस इज ऑल फॉर द टुडे क्लास बिकॉज टाइम इज ऑलरेडी, अब नेक्स्ट क्लास है. ठीक है? तो तुम लोग इसको ट्राई करो सॉल्व करने का एंड इसको एक बार रिवाइज करो. आई एम गोइंग टू प्रोवाइड यू अ पीपीटी, नो वरीज. ठीक है? सारे पीपीटी प्रोवाइड हो जाएंगे एक लिंक में, वहां से तुम लोगों को पीपीटी मिल जाएगा. क्लियर है? चलो, सो टेक केयर ऑल. आई होप सबने नोट कर लिया ना ये क्वेश्चन. ठीक है, चलो, तो टेक केयर ऑल. मिलते हैं नेक्स्ट क्लास में, वहां हम लोग डिस्कस करेंगे फिर.